Moving on, next topic would be force on a current carrying wire placed, write down the topic, force on a current carrying wire placed in the magnetic field of another wire. See, I have a wire, I have this conductor, alright, I have this direction of current flowing through it. Now, what would be the direction of magnetic field due to this wire? Right hand thumb rule like this, so there will be dots here and these are dots and cross here, right? So this is the magnetic field due to this wire having current I1. If I placed another current carrying wire in this region where magnetic field is present due to this wire, that conductor is also going to experience the force, which force is given by BIL. So this is what this topic is about, force on a wire placed in the magnetic field of another wire or conductor. See, first of all let me at this distance r, I am writing I am finding out the magnetic field due to this wire. So magnetic field B1 due to this conductor carrying current I1 at distance r would be equal to mu naught I1 upon 2r. Where is this formula coming from? Because this length is non-mentioned, so I will be taking it as an infinite length, right? So force on another wire or conductor placed at this distance having current I2, the force on the conductor would be given by BIL, length of this conductor or overall upper unit length of this conductor, but I have to consider the length. Let us say this much length is placed here. So force experienced by this conductor due to magnetic field this would be force is BIL, which I, first of all magnetic field is present due to the first wire, so I am taking B1, current is flowing in itself because our previous topic was what? Current carrying conductor placed in a magnetic field experiences a what? Force, and current carrying coil, okay, I'll go to the torque part next time, but right now it is the current which is flowing in this conductor is causing the force to be applied on this wire due to this magnetic field, and it will make your formula to be mu naught I1 upon 2r into I2L. So this is the formula for force per unit length. Force per unit length of this wire or conductor placed in the magnetic field of another conductor is this is the formula. A very interesting fact is this right now. See the direction of force. How do we find the direction of force? Force, field, current. Now till now this point you have already remembered this rule, right? Force, field, current. I don't know force, but I know the direction of field, vertically inwards, and direction of current is upwards. So the direction of force is towards the another conductor, right? That means two current carrying coil or two current carrying wires having current in same direction attract each other, right? If they are this goes like they attract each other because force in each is coming towards each other. Now see this, I have a spring here, I have a spring attached with a bob such that the bob is just touching the mercury placed in this container. Okay, I have a wire here which is connected from this battery, and I have connected this wire to here. I also need to put a switch. If I make this kind of circuit, what will happen? The moment I close the switch, current will flow in the spring, and each two part of the spring will have current flowing in same direction. So what will happen? They will tend to contract. But right now when the current flows, circuit is getting completed, but when current flows in the same direction, the spring is going to contract, which will pull this bob up. The moment bob goes out of contact with the mercury, the connection breaks, and hence this attractive force disappears and it will fall back due to its weight. The moment it touches the mercury again everything will happen and it will bounce back. So what will happen? This kind of SHM motion will keep on happening here. Alright, So this was force in the magnetic field of another wire on another conductor.